Okay, in this short video, I'm just going over how to solve equations with variables appear on both sides. So when we were solving equations last week, each equation, the variables, the terms with the x or the m or the p, were always on either the left side or the right side. In this equation, I have a term with a variable on the left side and the right side. So our goal is the same. When we finish this problem, what I would like is to know, well, what is x equal to? So at the end of this problem, I'd like to have x on its own. So what I need to do is I need to get all of my x's onto one side of the equation. So I really want to get rid of this positive 4x on the right side. So I need to do the opposite operation. The opposite of plus 4x would be subtracting 4x. If I do it to one side of the equation, to keep that equation balanced, I've got to also do it to the left side. So I'm going to subtract 4x from my left side as well. Now I can kind of collect like terms. I can't add the 9 to the 7x to the negative 4x. Those aren't alike. But I can do 7x minus 4x is 3x. And I still have plus 9. And on the right side of my equation, I still have that positive 15. But 4x take away 4x is nothing. So now I've kind of transformed this equation. I've moved all the x's to one side, and now it looks more similar to the type of questions that we were doing last week. Now I want to isolate for x, so I'm going to subtract 9 from both sides. So I'm getting closer. I've got 3x equals 6. And then now I've got 3 multiplied by x. I really want x by itself, so I've got to do the opposite of multiply by 3. So I'm going to divide by 3 on the left, and then, of course, always do the same thing on the right. 3x divided by 3 is 1x, and then 6 divided by 3 is 2. So I went a little bit quickly through those latter steps because it is similar to what we've been doing last week. The only thing that is new today is that before I can start isolating for a variable, I need to make sure that all of the terms with that variable are on one side of the equation. Let's do a couple more examples together, and then you'll have some practice to do in your booklets. Again, I can't collect things on different sides of the equal sign. So I can't collect the negative 4x and the negative 6x. I can't just put them together because they're on different sides of the equation. So instead, I want to move all of my x's to one side of the equation. So I can do plus 6x when I was doing the opposite operation. And if I do something to one side, I have to do the same thing to the other side to keep my equation balanced, to keep the left side equal to the right side. Negative 4x plus 6x, negative 4 plus 6 is positive 2, so I have 2x, and I copy down the minus 3. And on the right side, negative 6x plus 6x, well, that's just nothing, it's 0. So I'm still left with negative 13. So I've moved successfully all my x's onto the left side. Now to isolate that x, so eventually I want to get x by itself on the left side. I want to get rid of this negative 3, so I'm going to add 3 to both sides. So now I have 2x equals negative 10. Negative 13 plus 3 is negative 10. Here I've got 2 times x. The opposite of times 2 is divide by 2. And I want to do that to both sides. So my final answer is negative 10 divided by 2 is negative 5. So our goal always when we're solving equations is each step needs to be a balanced equation. I ensure that by always doing the same operation to both sides. And I've written those in green. So I've got plus 6x plus 6x, the same operation. Plus 3 and plus 3, and then divide by 2, divide by 2. So I'm always doing the same operation to both sides. So each step, the left side is equal to the right side. When I'm done the equation, I should have isolated x. So the variable is by itself on either the left or the right side. Let's just do one last question. This one is a little bit longer. Kind of combines what we were working on previously with what we've been doing today. Sorry, give me a second to adjust this camera. Before I start moving things around the equation, before I start trying to solve, I'm going to always look to see if I can collect any like terms. It's always easier to solve if my equation's a little bit simplified. So I'm going to collect the left and the right sides separately. I can only collect terms that are on the same side of an equation. So on the left side, I can collect 5x and positive 3x. I've got 8x and then minus 3. I can't do 8x subtract 3. Those aren't like terms. On the right side of the equation, I can collect negative 9 and negative 10, so I'm left with 10x minus 19. So my advice is always look to collect like terms on either side first. And now what I want to do is try to move all the x's to one side of the equation, and then move all the constants or all the numbers to the other side of the equation. Now you can choose. Some students prefer to always put the variable on the left side. So then I could do minus 10x minus 10x. Other students really like to avoid negatives. So if I did minus 10x and minus 10x out of negative 2x on the left, some students don't like negatives. So instead, they might notice, hey, if I actually move the x's onto the right side, if I do minus 8x and minus 8x to both sides, I have no more x's on the left. I just have negative 3. And on the right, 10x minus 8x, I get a positive 2x, and I still have my minus 19. So if x is on the right, at the end of the problem, I'm going to have equal x on the right side. So then I need to move this negative 19 onto the left side. So I'm going to do the opposite operation of negative 19 is plus 19 to both sides. Negative 3 plus 19 is positive 16 equals 2x. And then I don't want that times 2, so I'm going to do the opposite, divide by 2 to both sides. And so my final answer is that 8 equals x. So you can gather your variables on the right side or the left side, but either way you will get the same answer. So it's your choice. Some students like to always put the variables on the left. Some students like to always keep the coefficient on their variable positive. Either way we'll get the same answer, and it's around the same number of steps. So that's how we solve equations when we have variables on the left side and the right side. You've got some practice to try. If you have any questions or you need any help, please don't hesitate to send me an email. Okay, that's all for now. Thanks.